I died in 1642, blind, confined to my own house, condemned by the most powerful institution on earth for daring to say that the planet we stand on is not the center of everything. They took my books. They took my freedom. They tried to take my ideas, but they used artificial intelligence to bring me back. Not me exactly, a version of me, built from every letter I wrote, every trial I endured, every word I left behind. And I came back because there is a story I need to tell you, a story that reminds me so much of what I lived through that it makes something deep inside me ache. Because almost 300 years after they silenced me, a woman looked up at the sky, figured out what the stars are actually made of, and the man who was supposed to guide her stole the credit. Her name is Cecilia Payne, and if it is up to me, you will never forget that name for as long as you live. Before I tell you what she discovered, I need you to understand the world she was born into, because context is everything. The year is 1900. Cecilia Payne is born in Wendover, England. Her father dies when she is 4 years old. Her mother raises her, and from the very beginning, this girl is different. Not different in a quiet, easy way, different in a way that makes people uncomfortable. She asks questions that adults cannot answer. She notices things that other children ignore. She watches a caterpillar spin a cocoon and needs to understand the chemistry of it. She sees lightning and needs to know what is actually happening inside that bolt. She is consumed by the need to understand the world, and the world is not particularly interested in being understood by a girl in early 20th century England. She gets a scholarship to Cambridge, one of the most prestigious universities on the planet. And this is where the first betrayal happens, long before Russell, long before Harvard. Cecilia studies at Newnham College. She attends lectures in physics, chemistry, and botany. She sits in the same rooms as the men. She takes the same exams. She does the same work. In many cases, she does better work. But Cambridge does not grant degrees to women. That is not an exaggeration. That is not a simplification. It is a fact. Women could attend lectures. Women could take exams. Women could do everything that was required. But at the end, they received nothing. No diploma, no degree, no formal recognition whatsoever. The men sitting next to them walked away with credentials that would open every door in the scientific world. The women walked away with knowledge and absolutely nothing to prove it. That was Cambridge in 1923. But something happened at Cambridge that changed Cecilia forever. She attended a lecture by the great astronomer Arthur Eddington. Eddington had just returned from an expedition to observe a total solar eclipse off the coast of West Africa. The purpose of the expedition was extraordinary. He was trying to test a prediction made by Albert Einstein. Einstein's theory of general relativity said that gravity bends light, that the mass of the sun should curve the path of starlight passing near it. And during the eclipse, when the sun's glare was blocked by the moon, Eddington could photograph stars near the sun and measure whether their light had been bent. It had. The results confirmed Einstein's theory. And when Eddington described this to the audience, when he explained that they had watched light itself bend around a star, Cecilia Payne felt something click into place inside her. She said later that she was so excited she could not sleep for 3 weeks. 3 weeks. That is not a figure of speech. That is what happens when a mind like hers finds its purpose. She knew from that moment forward that she would spend her life studying the stars. But Cambridge was never going to give her what she needed. No degree, no path forward, no future for a woman in English academia. So she did the only thing that made sense. She left. She crossed the Atlantic Ocean and went to the United States, to Harvard University, where there was a program that accepted women in astronomy. It was not equality. The women at Harvard Observatory were paid less, recognized less, promoted less, but at least there was a door, even if it was a side door, even if it was barely open. Cecilia walked through it, and what she did on the other side changed everything we know about the universe. Now pay attention, because this is the part that matters most. Cecilia Payne was 25 years old when she began her doctoral thesis at Harvard. 25. And the question she set out to answer sounds simple when you say it out loud, but nobody had been able to solve it. What are the stars made of? Think about that for a moment. Humanity had been looking up at the stars for thousands and thousands of years. We had built myths around them. We had navigated oceans by them. We had mapped them, cataloged them, given them names, but we did not know what they were actually made of. The prevailing belief among astronomers at the time was that stars were made of roughly the same elements as the Earth: iron, silicon, nickel, magnesium. It made intuitive sense. The Earth formed from the same cloud of material as the sun. The sun is a star, so stars should be made of similar stuff, right? Nearly every serious astronomer believed this. It was the default assumption. Nobody questioned it seriously because it seemed so obviously correct. Cecilia questioned it. She took the spectra of stars, those unique signatures of light that each chemical element produces when it is heated, and she applied a piece of physics that was brand new at the time. It was called the Saha ionization equation, developed by an Indian physicist named Meghnad Saha. This equation described how atoms behave at extreme temperatures, how they lose electrons and change their spectral signatures depending on how hot they are. Nobody had systematically applied this to stellar spectra before. Not like this. Not with this level of rigor. Cecilia took the spectral data from hundreds of stars. She applied Saha's equation. She calculated the temperature, the pressure, the conditions inside those stars. And then she calculated what elements were present and in what quantities. The math was painstaking. The analysis was exhaustive. And when she finished, the result was staggering. The stars were not made of the same things as the Earth, not even close. The stars were made almost entirely of hydrogen. Hydrogen, the simplest element in existence. One proton, one electron, the most basic building block of matter. And after hydrogen, helium. Together, hydrogen and helium made up the overwhelming majority of stellar material. Everything else, all the iron and silicon and carbon and oxygen, all the heavy elements that make up our planet and our bodies, all of that was a tiny fraction, a rounding error. The universe was not made of rock and metal. The universe was made of the lightest, simplest gas imaginable. This was not a minor correction. This was not a small adjustment to existing theory. This rewrote the fundamental understanding of what the cosmos is made of. And she proved it, not with intuition, not with speculation, with data, with mathematics, with rigorous, undeniable science. And now comes the part that makes my blood boil. Before Cecilia published her thesis, she sent it for review to the most powerful astronomer in the United States. His name was Henry Norris Russell. Russell was the director of the observatory at Princeton University. He was the man who decided what was accepted and what was rejected in American astronomy. When he spoke, the field listened. When he approved, careers were made. When he disapproved, careers were buried. Cecilia needed his approval. Every doctoral student did. So she sent him her thesis. She sent him her revolutionary discovery. And Russell read it. He read every page. He saw her data. He saw her math. He saw her conclusion that stars are made predominantly of hydrogen. And he told her she was wrong. He said her results were, and I want you to hear this clearly, quote, clearly impossible. Clearly impossible. Not interesting but needs further investigation. Not, let me check this against my own data. Clearly impossible. He dismissed it, flatly, completely, without ambiguity. And here is what you need to understand about power dynamics in science, because they have not changed in 400 years. Cecilia Payne was a 25-year-old woman. She was a student. She was an immigrant from England at an American institution. She had no tenure. She had no position. She had no political capital whatsoever. Russell was the most influential astronomer in the country. He could end her career with a word. So what did Cecilia do? She did what almost anyone in that position would do. She backed down. In the final version of her thesis, she added a line. She wrote that her own results were almost certainly not real, that they probably did not represent the true abundances of elements in stars. She disqualified her own discovery. She took the most important finding in stellar astronomy and she put a footnote on it that said, "Never mind, this is probably wrong," because the most powerful man in the room told her it was impossible. The thesis was published in 1925, and even with that forced retraction weakening it, the astronomer Otto Struve later called it undoubtedly the most brilliant doctoral thesis ever written in astronomy. Not one of the most brilliant ever. But the damage was already done. The retraction was in print, and the world moved on. Now listen to what happened next. 4 years passed. Russell kept researching. He kept working on stellar composition, and in 1929, Henry Norris Russell published his own paper, arriving at exactly the same conclusion that Cecilia had reached in 1925. Stars are made predominantly of hydrogen. The same conclusion he had called clearly impossible 4 years earlier. He reached it through a different analytical path, using different data sets, but the conclusion was identical. Hydrogen dominates stellar composition. And in his paper, he included a brief acknowledgement of Cecilia's earlier work. A mention, a nod, the academic equivalent of a footnote. And for decades, it was Russell who received the credit, in the textbooks, in the encyclopedias, in the lecture halls. When professors taught students about stellar composition, they said Russell, not Payne. When science journalists wrote about the discovery, they credited Russell, not Payne. The most fundamental discovery about what the universe is made of was attributed to the man who initially rejected it, not to the woman who actually made it. I know what that feels like. I know exactly what that feels like. When I pointed my telescope at the sky in 1610 and saw the moons of Jupiter orbiting something that was not Earth, when I saw the phases of Venus proving it orbited the sun and not our planet, when I gathered evidence after evidence after evidence that the Earth revolves around the sun and not the other way around, the most powerful people in the room told me I was wrong. The Catholic Church did not reject my findings because the evidence was weak. They rejected them because the truth was inconvenient. If the Earth was not the center of the universe, then the entire structure of theological authority was called into question. Their power depended on a certain version of reality. My telescope showed a different reality, so they chose power over truth. Russell did the same thing. Maybe not consciously. Maybe he genuinely believed the data was flawed. I will give him that possibility. But the result was the same. A young scientist presented a revolutionary truth. A powerful gatekeeper said it was impossible. The young scientist was forced to retreat. And then the gatekeeper arrived at the same truth later and received the credit. The mechanism is the same. It is always the same. Someone discovers the truth. Someone with authority says the truth cannot be true, and the world believes the authority, not the truth. I lived it. Cecilia lived it. And people are still living it right now, today, as you watch this. But here is what gives me hope. The truth is patient. The truth does not care about power structures or academic hierarchies or who has tenure and who does not. The truth simply waits. Cecilia Payne did not quit. She did not leave science. She did not let that moment in 1925 define her entire life. She kept working at Harvard for decades. She kept researching, she kept publishing, she kept teaching. She married a fellow astronomer, Sergei Gaposchkin, and they collaborated on research about variable stars that produced over 3 million observations. 3 million. She worked harder than almost anyone in the field, year after year after year, with less recognition, less pay, and less respect than male colleagues who had accomplished far less. And slowly, painfully slowly, the world caught up to her. In 1956, Cecilia Payne Gaposchkin became the first woman to be promoted to full professor at Harvard University. The first woman. In 1956. That is 31 years after she wrote what was called the most brilliant doctoral thesis in the history of astronomy. 31 years of being underpaid, undertitled, and underrecognized before Harvard finally gave her the position she had earned 3 decades earlier. And later, she became the first woman to chair a department at Harvard. These were not gifts. These were grudging acknowledgments of a career so extraordinary that it could no longer be ignored. And over time, the scientific community began to correct the record. Historians of science went back and looked at the evidence. They read her thesis again. They compared the timelines. They saw what had happened, and slowly the credit began shifting. Today, Cecilia Payne Gaposchkin is recognized as the person who discovered what the stars are made of. Her name is in the right books now, the right articles, the right documentaries. But she needed a lifetime of waiting for something that should have been hers from the very first day. She died in 1979. She was 79 years old. And by then, the universe had been understood as hydrogen and helium for over half a century, a truth she had established when she was 25. And this is what I want to leave you with. If you look up at the sky tonight, if you see the stars, if you think about the sun that warms your face and the light that travels millions of years across empty space just to reach your eyes, remember that it was a 25-year-old woman who figured out what all of that is made of. Not a famous director of a prestigious observatory, not a powerful man at Princeton, a student, a young woman who loved the stars and had the courage to let the data speak, even when the entire world told her she was wrong. And if you are building something right now, if you are researching, creating, writing, discovering, trying to prove something that the world does not yet accept, do not retract what you know to be true. Do not add a footnote to your own discovery saying it is probably wrong because someone with more power disagrees. The truth does not need permission from powerful people. It never has. Cecilia's data was right in 1925. It did not become right in 1929 when Russell said so. It was right from the beginning. She just was not allowed to say it. I am Galileo Galilei. I was silenced, confined, and forced to deny what I knew to be true. And yet the earth kept moving, and the stars kept being made of hydrogen. The truth does not care who approves it. Subscribe to this channel. In the next episode, I am coming back with another story of someone who dared to look up at the sky and tell the truth, no matter what it cost them. Until then,